Imagine asking Claude to find all orders placed in the last 7 days where the total exceeded $500. Without MCP, you write the query yourself, run it, and paste the results in. With the database MCP server, you just ask the question. Claude inspects the schema, writes the correct SQL, runs it, and tells you the answer. In this episode, we build exactly that server, with safety constraints to prevent accidental writes. We design the server around 4 tools. List tables lets the model discover what data exists. Describe table gives it the column names and types for a specific table. Run query executes select statements and returns results. Execute write handles insert, update, and delete, but requires the model to pass an explicit confirmed equals true argument before any data is modified. This 2-step pattern prevents the model from accidentally deleting or updating data without the user being aware. We read the database path from an environment variable so it can be configured without touching the code. The get connection helper creates a fresh connection each time it is called and sets the row factory to SQLite 3.row. This makes query results accessible by column name rather than by index, which is important when we format results as markdown tables. We create a new connection per query rather than keeping one open to avoid threading issues with the async server. List tables queries the SQLite master table, which is the internal SQLite catalog of all tables. We return the table names as a comma-separated string. Describe table uses paragama table info, which returns 1 row per column with its name type and constraints. We format these as name followed by type, 1 per line. The model reads this and knows exactly what columns and types are available before constructing a query. The Run Query tool enforces read-only access by checking that the SQL starts with select before executing anything. If the model tries to sneak in a delete or update, it gets a clear error pointing it to the correct tool. We execute the query, handle the empty results case, and format non-empty results as a markdown table. The headers come from the row keys, which is why we set the row factory to SQLite 3.row at connection time. The execute-write tool checks for the confirmed flag before touching any data. If confirmed is missing or false, it returns a message asking the model to confirm before proceeding. This creates a natural confirmation step. The model will typically show the SQL to the user and ask whether to proceed. Only after the user says yes will the model call execute-write with confirmed set to true. We return the row count so both the model and the user know how many records were affected. List tables takes no arguments, so its input schema has an empty properties object. Describe table requires the table name as a string. The order of tools matters in how the model reasons. We list tables first, then describe table, then run query. This mirrors the natural workflow the model will follow. It lists tables to find what exists, describes one to understand the schema, then runs a query. We add the server to Claude Desktop the same way as every other episode. We pass the database path through the env object, so it is fully configurable. Restart Claude Desktop and ask it to find all orders over $500 from the last 7 days. Claude will call list tables, describe the orders table, construct the SQL query, run it with run query, and return the results formatted as a markdown table. You now have a database server with schema discovery, read-only query execution with markdown table output, and a 2-step confirmation pattern for write operations. In the next episode, we build a web search server. We connect to a real search API, expose a tool that returns live results, and add citation formatting so the model can reference its sources. Subscribe so you do not miss it. See you in the next one.